So you remember those pyramids that I had in my classroom? They're up on my desk on the corner. And some of you wonder, like, why do you have all these pyramids up there? What are these all here for? Well, it turns out they're there literally for today. And the problem is they're still there, and I'm here. So that's kind of a bummer, but I do have this I can show you. We're talking about pyramids today, and this is a tea bag, a very fancy one apparently, that is built like a pyramid. I don't know if you can really see the shape here. It sits on a triangular base, and this is what we call a triangular pyramid. So it has a triangle base, and then there's three triangular sides that go up to a point. Now we can have a rectangular pyramid, which has a rectangle on the bottom. Usually would be a square. It's most common to find a pyramid that has a regular polygon, like an equilateral triangle or a square, regular pentagon, something like that. So that each of the triangles are the same dimensions going to a single point. So we're going to take a look at volume and surface area of these pyramids. But before we do that, we're going to start out with cones. And I thought, well, what's the best way to describe a cone? And I thought, you know what, maybe I'll just have to have an ice cream cone. So you can see this delicious cone, not a real big one, but we're going to take a look at how much ice cream fits inside, and then also how much cone it takes to make the cone. So I'll take a quick bite. Delicious. And we'll get to work. So volume is kind of interesting here. Now I'm going to show you this because it turns out that with a pyramid and a cone, their volumes are directly related to the volume of the shape that would be if there wasn't a single point at the top. So let me just draw this real quick. So here we've got a cone. Looks like this. And then what I want you to imagine is that there is also this idea that a cone is just cut out of a cylinder. And it's actually really simple. The volume of a cone is exactly 1/3 of what the cylinder volume would be. Remember that from last week? We had, remember the cylinder was all these circles on the bottom, and then they were just, stacked up. Just stack, all the way up to the top where we get this circle on the top. So it was pi r squared, the circle, times the height h. So that's our formula. That's our volume formula for a cone. And I thought we could maybe do a little problem. So let me switch over here. And here is a nice big cone. Much bigger than the one that I'm snacking on over here. So take a look at that real quick. We have a cone with a 2-inch diameter. Now remember the difference between diameter and radius. And then I've got 6 inches of height. So let me go back. So you got this picture, right? If you want to sketch it, you can. I'll try to sketch it the right direction, but I'm going to switch back over to the whiteboard again, go to a new page, and we will sketch this cone. So the first thing we have is, maybe I can do this. Ooh, look how fancy that is. And then we'll go down here, make it nice and tall, and we'll come down here also. Okay, that's a fine looking cone, my goodness gracious. Pandemic will not beat us here, we will get this. So this is 2 inches. And then to be really accurate here, I want to make sure that we got this right. This right here is 6 inches. Okay. So the question is, how much ice cream do I get? Volume is 1/3 pi. Now remember, it's r squared. R is going to look like, try to get three-dimensional there on you. R is going to look like that, and it should be 1 inch. So it's pi times 1 squared times the height, 6. That's 1/3, by the way. So make sure you get that. It's 1/3 pi r squared times h. And it's interesting, I'm hoping to have these for next year. I'm not going to help you at all, but they actually sell these clear plastic cones. It's for instructional purposes with holes in them. And so you can fill them with water. And so what I like to do is I can also get them with the cylinder. And so I'll take a cone, the same size and dimension, fill it up with water, pour it into the cylinder, fill it up again, pour it in the cylinder, fill it up a third time, and it comes out. I mean, it has to come out right. That's what it is. So what is this going to look like? Well, 1/3 of 6 is 2. It's 2 pi. So we're getting about 6.28. Now, what would the units be here? I've got inches here and I've got inches there, but remember that the area of a circle would be in square inches. So I have square inches there times inches there. This is actually cubic inches, cubic for the volume. Okay? All right, well, let's go on to a pyramid. And I wish I had really funny stories for the volume of a pyramid, but people don't eat pyramids very often. For some reason, we like to eat cones. We don't eat pyramids. So when I move to the pyramid world, it's not nearly as exciting, but it is kind of exactly as we anticipated. So let me see if I can draw this. I'm drawing freehand here, so it's not going to be ideal. But I'm going to have a point here, and then I'm going to draw lines down here. Oops. There, there, and there. Decent, yep. And we've got this, put this point right down here. It's going to be like right in the center of the pyramid. Does that make sense? So it's like I'm dropping a rope straight from the top of the pyramid down to the bottom. And this spot right, let me draw it, then I'll take it off. But this spot right here is the exact center of that square, okay? So let me show you one that's got some little interesting more dimensions that we'll look at here. And we'll tackle the line with this. So here is a pyramid. It's a square pyramid. Again, I'm just looking at this tea bag. This tea bag has a triangular base, which is fine, but we're looking at a square pyramid in this example. And it's 10 by 10 with a height of 18. Okay, so let's remember that. We'll go over to the whiteboard here, and I'll label some of these dimensions. So this is 10, I think it was inches. Let me double check. Oh, centimeters. I was way off. Let's get it right. Centimeters. This is 10 centimeters. And then this right here, the height of the pyramid is 18 centimeters. So remember, and this is going to get a little bit messy, and I'm sort of hesitant to do this, but I want to show you that in theory, you know, this could be a cube, right? Can you see that, or at least a prism? And the pyramid is just a portion of that prism. Let me take this all off because it's a bit distracting. So the volume now is going to be 1/3 of whatever that prism volume would have been. which we're going to write as big base B, that's all this, times height. So the actual calculation is not going to be that difficult. The base that I've got marked in green here is 10 by 10. That's going to be 100. And by the way, that is square centimeters. Then the height is going to be 18. So I know when some of you look at that, and this is actually centimeters here. So when some of you, when you look at that, you're like, oh, I don't know how to multiply that. But let me show you something kind of cool here. I think I can multiply. Remember, I know algebra was not great for some of you. But one of the properties of algebra is you can multiply things in any order. It's the commutative property, or sometimes even the associative property of multiplication. So I can actually multiply this number times that first. So can you think about what's a third of 18? Oh, 6. Oh, 6 times 100, 600 cubic centimeters. So our goal for calculating volume of a pyramid, or really for a cylinder, is to find the area of the base. So it's the same thing again here. It's 1/3 area of the base times the height. It's the same formula, guys. It's just that for a cone, the base happens to be a circle. So we use this pi r squared. So it's 1/3 pi r squared h. And then if we move to a pyramid, as long as it's a square, then it's just 1/2 this square area. 1/3 is square area times height. But I mean, again, I could do a triangle, or I can have any sort of crazy shape. We won't do that. But the bottom line is the volume is 1/3 of what the volume would be if it was a prism or a cylinder. Okay? Now, here's where it gets tricky. And this is where I get a little bit frustrated with your book, because your books don't even cover this. But they should. So I want to talk about surface area. Specifically, remember I said one of the interesting things is how much ice cream goes on the inside. But what's also interesting is how much cone. I'm delicious. Wow. How much cone they have to make on the outside. So I'm interested in two things here: what I can put in it and what I need to make of it. So what I want to do is I want to replicate. Let me start with the pyramid actually this time. It's a little bit easier. I'm going to replicate this pyramid again. Okay, this one with 10 by 10 and 18. And it's going to be a little bit funky. It's going to take a few minutes for us to get through this, but I think it might be worth it. I don't know. You might prove me wrong. So let me go here, 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 here. I'll put my dot up there. Draw lines there. Whoops, I don't want to do that. Line. There, there. Okay, not bad. So I want you to think about surface area now. For sure, part of the surface area of this pyramid is going to be the base of the pyramid. Like even this little triangular guy here, they had to make stuff, this little mesh stuff for this tea bag that was in the shape of the triangle. So I've got to have the area of the base. So the surface area for a pyramid is going to be the area of the base, for sure. And in our example, it's 10 by 10. So it's just a square base. So that's not going to be too terribly difficult. That's not the hard part here. Plus, and this is where it gets a little bit tricky. Now I've got, do you see the 4 triangles here? I'll see if I can shade some. Here's one of the triangles on the right side. And here's a triangle on the left side. Then I'll maybe change color here. This one here is the triangle on the front side. And then there's one around on the back side. So basically I have 4 triangles. And to be clear, again, I have 4 triangles because my base has 4 sides on it. If I had, I don't know, a hexagon base, I'd have 6 triangles. And if I had a triangular base, I'd have 3 triangles. So I have as many triangles as I have sides on my base. All right, so let's talk about the area of a triangle. Area of a triangle is 1/2 base times height, right? So if I were to look at, this is gonna get a little bit crazy, but I'm gonna look at just this triangle right here, this side triangle. I hope you will agree that the base of this triangle is this, which I'm gonna call S, the side of my square. Now the height is tricky because the height is not the height of the pyramid. Remember that was 18 centimeters? The height of the triangle is that distance. Can you see that? It's on the outside edge and it's longer than the height of the pyramid. We call it the slant height, and I'm just going to call this L for slant height. And listen, guys, I know this is super hard to learn by watching the video, and I'm sorry about that, but we'll do the best we can. So this black triangle has an area of 1/2 this base times this slant height. And the thing is, all 4 of these triangles are the same. So this new surface area is going to look like base plus 4 times 1/2 SL. L is the slant height. But guess what? Yeah, I know you probably can't get it. If I go around the perimeter of this base, doesn't that give me 4 S's? So this is S, this is S, this is S, this is S. So 4S makes the perimeter. So this I can replace with a perimeter, and I get this really funky equation, but it's not that bad. It's area of the base, we know that, that's the red striped area, plus 1/2, whoops, plus here, plus 1/2 PL. That's the surface area of a pyramid. So let's think about this. You find the area of the base, then it's 1/2 the perimeter of the base, which is pretty easy to figure out. It's going to be 40 centimeters here, times this slant height, L, which is not going to be super easy to figure out, but we can do it, and I'll show you how in just a second. So that's a formula, and you're going to want to write this down. It's not in your book. So how do we find this slant height? Well, I'm going to draw a triangle here that looks like, I don't want to do it. It's going to look like, what am I doing? There we go. This, and this. Okay, bear with me as I draw this triangle on my drawing here. It's going to get a little bit funky here, but bear with me. The first part of the triangle goes straight down. Second part of the triangle goes over like that. The third part of the triangle is this slant height. Okay, so that there in the middle, this right here, moves right over and is this thing right here. Okay? Told you it could be a little bit hairy, but we're going to figure this out. Now, remember, this point in the middle here is exactly the midpoint of the base. So this bottom leg is going to be 5 centimeters. And we already know the height is 18 centimeters. And this is our slant height. How in the world are we going to find that? Oh, wait. I know what that is. You know what that is? Pythagorean theorem. 5 squared plus 18 squared equals L squared. Okay, 25 plus 18 squared. I'll save you the hassle. 324 equals L squared. So L squared equals, add those up, 349. Now I don't know what the square root of 349 is, but this guy does. So the square root of 349 is 18.68. So L is 18.68. Well, now I have everything I need to find the area of the surface area of my pyramid. The base was 100, right? That's the just back in red. That's this area of this flat, in this case, square base, plus 1/2. What was the perimeter? The distance around the base was 40, and the slant height was 18.68. And I simply add them up. 100 plus 0.5 times 40 times 18.68. And now the total surface area of my fancy little pyramid there is 473.6. Now, this is area, not volume, so it's centimeters squared. And that's how I do it. So yeah, that's a lot of work, isn't it? But keep in mind that once you have this, I've done all the really heavy work for you. All you have to do is figure out that. I can do this. This is cool. You have to figure out that. And if you can set that triangle up, and I hope you can see that triangle in the original problem, then you just use Pythagorean theorem and off you go. All right, the last one is a little bit tricky because cones are kind of funky. So let's go through this again. Let's draw a cone here. And this time I'm going to be a little bit cuter about it. I'm just going to draw this as my radius. I will draw this. Oh. This is my height. Okay, now, this is tougher. Why? Because over here, I could look at each one of these sides and think of those, oh, it's just a triangle. But what does it look like when you, I'm tempted to have another bite of this, but I'll try not to. If I peel this cone out, look, I can actually peel it out. You see that? Peeling it out. See this right here? I can actually peel this cone out. What kind of shape is this cone going to make when I peel it out? And my answer is going to be on this other page over here. So let me show it to you. It's going to look like this. Ah, yeah. That's what I'm talking about. It's that blue thing right there, which is a portion of some funky circle, but it's not the entire circle. So the area of the cone, surface area of the cone, will certainly include, now they didn't do it with the ice cream cones because there's nothing on the top. That was, not to rub it in too much, but that was the top right here that I'm going to have after I get done. But the surface area of the cone tops with a circle, so we have pi r squared there. But it's this other sector piece that's really tricky. So let me come back and put this together for you so we have something that we can deal with. So this is for a cone now. The surface area, first of all, is this surface area here, which is just pi r squared, right? And then what we have to somehow account for is all of this stuff around the outside, that sector shape. I'm just going to give it to you. It's pi r L. And I'm using L, some books and some references use different letters for that. But L is once again going to be this length right there. That's L, slant height. So I have height here, slant height there. How do I find that? Well, it's just another triangle. I have height, I have radius, and I have slant height. So H, L, R. So let me give you an example problem. I'll just add the numbers to this. I have a cone here with a 6-inch radius. It's 10 inches tall. And I want to not only make the ice cream cone, but I want to cover it on top as well. So what's the surface area? How much stuff do I need? Well, it'll start with pi times 6 squared. That's just going to be 36 pi. Plus, now we got to be careful here. Pi is a number, the radius is 6, and this L, that's the thing we have to solve for. But it's not impossible. You're in May of your year of geometry. You can do this. You can do this. 10 there, 6 there, 6 squared plus 10 squared with L squared. 36 plus 100 equals L squared, which is 136. And L is approximately 11.66. 11.66 inches. So 11.66. So now I multiply. Now here's what I'm going to do. Watch. I'm going to multiply that times 6 and just get 69.97. So it's going to be plus 69.97 pi. I'm tempted to call it 70 pi, but I'm just going to call it 70 pi. So 36 pi plus 70 pi makes 106 pi square inches. Now in the test, I'm going to give you the option of leaving your answers in terms of pi, which is really nice to do if you have a circle. But I'm also going to let you multiply it out if you want as well. Okay. So this is the formula you want to have for, oh boy, for surface area of a cone. So what do we get here today? Well, we started with volume of a cone, 1/3 pi r squared h, 1/3 base times height. Then we have the volume of a pyramid, which is again 1/3 base times height. It just matters what shape the base is that determines how you figure out the base. The surface area of a pyramid is this one in the lower left-hand corner here, base plus 1/2 perimeter times slant height. Then the last one is pi r squared, which again is the area of the circle that acts as the base or the top, plus pi rl. So that's a lot. And again, the surface area stuff's not in your book, but you get it from me. So here are your options for the week. Option number 1, page 484, 5 through 10, 17 through 24. Option number 2, another CUDA worksheet on surface area. Oop. That's pyramids and cones. Option 3 is the CUDA. You know where I'm going, don't you? Volume. Pyramids and cones. Okay, pick one. Now, I will tell you here, and you don't have to do this, but this one and this one only deal with volume. the one in the middle. If you want to play around with the surface area, you can do it. It's cool. It should be in your book, but it's not. So anyway, pick one of those. Have a great week. Happy May, and I will see you next Monday.